This says the table for the relation y equal px squared minus 5x plus q is this. Use the table to find the values of p and q. Now we have to find the values of p and q here. What we'll do is, you notice here that for the table x and y, we have complete coordinates and incomplete coordinates. For example, we notice here we have minus 3 and 21. Here we have minus 2 and 6. Here we have minus 1 and an empty space for y. So we have some incomplete coordinates like x, which is minus 1 here, x which is 1, 2 and 3. We have incomplete coordinates for these ones, and we have complete coordinates for the other one. So we can only use the complete ones, the coordinates are complete here, to find the values of p and q. What we'll do is we'll just pick any of these complete coordinates, substitute the values for x and y in this relation, then we'll find the value of p and q. Let's do that together. For the first one, which is 7a1, I can pick any of the coordinates. I'll pick 0, this coordinate 0 and minus 12. I'll say when x and y coordinate is equal to 0 and minus 12 excuse me, I'll substitute the value of x and y in this relation here. I would have something like when x is 0, y is minus 12. So put minus 12 here. I'll have minus 12 is equal to p. Then x is 0. I'll put 0 squared. See, this is x squared, so I just substitute x for 0. Then minus 5, I'll put 0 here because this is x, plus q, plus q, plus q. This is minus 12 equal to 0 squared is 0. So p times 0 is going to give us 0. So that will be 0 minus 5 times 0 is 0 plus q. Plus q. This is minus 12 equal to 0 minus 0 gives us 0. Then this is plus q. So we'll have plus q. We can just say this is q is equal to minus 12. Minus 12. Minus 12. And let's go to the next one. The next one is we need to find the value of p this time around. To find the value of q, excuse me, let's find the value of p. So we can pick any of the coordinates. We can pick any of the complete coordinates. I'll pick 4 and 0. This 4 and 0 here. We'll see when the x and y coordinate is equal to 4 and 0, would have just substitute x for 4 and y for 0 here. Would have 0 is equal to p, then put 4 for x, 4 squared minus 5 4 plus q. This is 0 equal to 4 times 4. 4 squared is 4 times 4, which is 16. So we'll have 16p minus 5 times 4 is 20. Then you know q is minus 12 here. We just substitute q for minus 12. We have minus 12, and this will be 0 equal to 16p minus 20. Plus times minus is minus. This will be minus 12, and this will be 0 equal to 16p minus 20, and minus 12 will give us minus 32. Minus 32. We can just take minus 32 to the left hand side, and we'll have something like 32 equal to 16p. Now you notice there's 16p here. We need to remove 16p is multiplying the unknown p here, so we need to cancel 16. We need to cancel 16 here to get p here, and we'll have just divide both sides by 16 to cancel p, or to cancel 16. So we'll have 16p all over 16 equal to 32 all over 16. So this 16 goes here 1, 16 goes here 1, 16 goes here 1, 16 goes in 32 2 times, and we'll be left with this will be 2 is equal to p. We can just say p is equal to 2. So this implies that therefore p is equal to 2 and q is equal to minus 12. Q is equal to minus 12. Now we can substitute this in this relation here and get a complete relation. Without y is equal to, where we have p, which is 2, we'll just substitute 2 there. We'll have 2x squared minus 5x. You know q is minus 12 now, so this will be plus minus 12, and this will be y is equal to 2x squared minus 5x. Plus times minus is minus. This will be 12. So this is a complete relation when we have a value of y, of p and q. Let's go to the next question. The next question here says copy and complete the table. Now, what they expect us to do is to bring this table down, find the value of y which is missing here. This one, this box, this box, this box. Find the values of y which is missing. So that's what we'll do. To maximize time, I'll not draw the table down. What we'll just do, we'll try to find the values of y and then put it back in this table. So see, for the first one here, we have x as -1 and we don't have the value of y. So to get the value of y, what we'll do there is we'll say when x is equal to -1, let's find the value of y. Just substitute x for -1 in this relation here. Anywhere you see x, just replace with -1, and we'll have y equal to 2. Then we'll just put here, we'll put -1 squared minus 5. Anywhere you see x, put -1 in this relation, and have -12. And this will be y is equal to, let me bring this down a bit. Now, -1 squared is just like -1 times -1. And you know, anytime you are multiplying two directed numbers, the result is always positive. So this will be +1. +1. So since this is +1, 2 times +1 is still 2. This is -5 times -1 will give us +5, then -12. And this will be y is equal to 2 plus 5 is 7 minus 12, and we'll have y is equal to 7 minus 12 give us -5. Okay, so let's go to the next one. We'll see when x is equal, let's go and write -5 up there. -5. This should be -5. When x is -1, y is -5. The next one is when x is 1, let's find the value of y. When x is 1, should be using the white color. When x is 1, let's find the value of y. Just substitute the value for just substitute x for 1 in this relation here. We'll have 1 squared minus 1, then -12. And this will be y is equal to 1 squared is 1. So you have 2 minus 5 times 1 is 5, then -12. And this implies that y is equal to, let's say 2 minus 5 and -12 give us -17. And this implies that y is equal to -15. So that when x is 1, y is equal to -15. So let's find the value of y when x is 2. When x is 2. So say when x is equal to 2, we'll just substitute x for 2 here. We'll have y is equal to 2 squared, just put x for 2, -5, 2, -12. So this will be y is equal to 2 squared is 2 times 2, which is 4. So 4 times this 2 give us 8. We have 8. 5 times 2 is 10, then -12. And this will be y is equal to 8 minus 10 minus 10 minus 12 give us -22. So 8 minus 22 here will give us -14. Okay, so when x is 2, y is -14. So when x is 3, let's find the value of y. When x is equal to 3, y is equal to, so just substitute x for 3 here in this relation. We'll have 3 squared minus 5, 3, then -12. This will be y is equal to 3 times 3. 3 squared is 3 times 3, which is 9. Let's just put this will be 9, minus 5 times 3 is 15, -12. So this implies that y is equal to 9 times 2 is 18, minus 15 minus 12 will give us -27. So 18 minus 27 is -9. So it means when x is equal to 3, y is equal to -9. So we've actually copied and completed the table. So the next question says, using the scales of 2 cm to 1 unit on the x-axis and 2 cm to 5 units on the y-axis, draw the graph of the relation for minus 3 less than x less than equal to 5. Okay, so we're given the scales for the x-axis 2 centimeters to represent 1 unit and 2 centimeters to represent 5 units. So we'll go to our graph on the y-axis. We'll go to our graph, write the title of our graph. Title, I'm saying title. It's very important you write, always put the title of your graph. Very important. As you say, a graph of y is equal to, let me see the graph. You just write the relation y equal to 2x squared minus 5x minus 12. Y equals to 2x squared minus 5x minus 12 when okay, minus 3 less than x less than equal to 5, minus 3 less than x less than equal to 5. So that would have minus 3, just say 4 minus 3 less than or equal to x less than or equal to 5. So 5 5. Now we have to, you notice that we are given scales of 2 centimeters to 1 unit on the x-axis and 2 centimeters to 5 units on the y-axis. So on the x-axis we are given 2 centimeters to 1 unit. 2 centimeters to 1 unit. What that means is, you know, on the graph here we have from here to here on the graph we have 10 small boxes. 10 small, you count, you have 1 2 3 4 5 6 10 small boxes before we get to this point. Now from this point to this other point is 2 centimeters. So from here to half of it, which is 5, is going to be 1 centimeter. Then the next one is 2 centimeters. So 5 holes gives us 1 centimeter. 2 small boxes gives us, if you have 10 small boxes like this, you have 2 centimeters. 2 centimeters. Let me clean this up. Finding it difficult to clean this. Okay, yeah, we have that. So we're told that using scales of 2 centimeters to 1 unit on the x-axis. So we'll go to the x-axis. We'll go to the x-axis. Let's take our x-axis as this. Let's take our x-axis as this. This will be our x-axis. Let this be our x-axis. Now for the y-axis, let's go to the y-axis. Let's go to the y-axis. For the y-axis, we were told to use 2 centimeters for 5 units on the y-axis. 2 centimeters for 5 units. 2 centimeters for 5 units on the y-axis. Let's take our y-axis from here. 2 centimeters for 5 units. Bring this down, please. Let's bring this down. Bring this down. Okay, it's okay like this. So 2 centimeters for 5 units. This is our y-axis. Let's take this as our 0 origin. So for the x-axis, we'll have to use 2 centimeters to 1 unit on the y-axis. 2 centimeters to 1 unit. Now we'll go to the table here. The highest on the positive direction, the highest value on the positive direction is 5. The highest on the negative direction for the x-axis is minus 3. And we're asked to use 2 centimeters to represent 1 unit. So what this means is this will be 2 centimeters to represent 1 unit. This is 1. On the x-axis, the highest positive is 5. So it means we must get to 5. So this is 2. This is 3. This is 4. And this is 5. So we must get to 5, and we can exit 5. We can also exit 5, but we must at least get to positive 5 on the x-axis. On the y-axis, on the negative direction of the x-axis, the highest value is minus 3. So it means we must get to minus 3. So this is, here we'll have minus 1, here we'll have minus 2, here we'll have minus 3. We can stop. Let's go to the y-axis. Let's see what we have on the y-axis. On the y-axis, we have to use 2 centimeters to 5 units on the y-axis. But on the positive direction on the y-axis, the highest is 21, and the highest negative on the y-axis is minus 15. Minus 15. So 21 and minus 15. We'll have to use 2 centimeters to represent 5 units. So this will be 5, 2 centimeters, 2 centimeters. 10. These 10 small boxes represent 2 centimeters for 5 units. You have 5, 10, or that 15, I would have 20. You know the highest positive on the y-axis is 20, is 21. So since it's 21, you know a box here, a box here represents, to know what a box here represents on the y-axis, all we'll just do is just say 5 divided by this 5 that we have here divided, from 0 to 5 you have 10 boxes here, say 10. So this 5 here, the first 5 divided by the 10 boxes, we want to know what one box represents, and this is going to give us 0.5. This is going to be 0.5. It means one box here represents 0.5, two boxes represent 1.0. If one box represents 0.5, two boxes represent 1.0. So it means if this is 20, two boxes represent 21. So this is 21 there. Now on the y-axis, the highest negative is minus 15. So we must get to minus 15. We are told to use 2 centimeters to represent 5 units. So this will be minus 5, minus 10, then minus 15. Then we'll stop there. We can stop there. So let's draw our graph now. Let's draw our graph. When x is minus 3, y is 21. When x is minus 3, this is minus 3 here, y is 21. So we'll just draw this. This is when x is minus 3, this is minus 3, y is 21. This is 21 here, this is y 21. So we just mark this point, Let's go again. Let's go. When x is minus 2, y is 6. When x is minus 2, this is minus 2. This is minus 2. When x is minus 2, y is 6. Let me see that again. Y is 6. Okay, y is 6. Now if this is 5, two boxes will give us two boxes after 5 give us 6. So it means 6 is here, 6 is here. So I'll just trace this out. Okay. So this is when x is minus 2, y is 6. Let's go to the next one. When x is minus 1, y is minus 5. When x is minus 1, this is x is minus 1, y is minus 5. This is y minus 5. So I'll just mark this. Let's go. This says, next one says when x is 0, y is minus 12. When x is 0, y is minus 12. This is x as 0 here. This one here, x is 0, then y is minus 12. Y is minus 12. This is minus 10 here. Two boxes will give us minus 11. Another two boxes will give us minus 12. So this is minus 12 here. We'll mark this point. Let me use another color circled because it's easily identified. Yeah, minus 12. Okay. Let's go again. When x is 1, y is minus 15. When x is 1, y is minus 15. This is x as 1. Let's trace it to minus 15. Yeah, this is y minus 15. So I'll mark this point. Let's go again. When x is 2, y is minus 14. When x is 2, y is minus 14. This is x is 2. Let's go to minus 14. Now if this is minus 15, if we go two boxes upward, if we move upward, there are just two boxes upward, we would have minus 14. So this is minus 14 here, this is minus 14 here. Okay, let's go to the question. When when x is 3, y is minus 9. When x is 3, y is minus 9. This is x as 3, traces down to minus 9. Now if this is minus 10, we have to go two boxes upward to get to minus 9. This is minus 9 here. Minus 9. Excuse me. This is minus 9. So let's go again. When x is 4, y is 0. When x is 4, y is 0. When x is 4, this is 4 here, y is 0. So mark this point. When x is 4, y is 0. That's that. Then let's go to the table. when x is 5, y is 13. When x is 5, this is 5, y is 13. So let's trace this up to y 13. Let's trace this up to y 13. If this is 10, the next two boxes give us 11. The next two boxes give us 12. The next two boxes will give us 13. Let's trace this out. Let's trace this out. Let's trace this out. Okay. So we're through with our points now. What we need to do is to combine all these points to give us a curve. So let's combine these points. Let's use another color. Let me see. Okay, this color is good. Let's combine these points. Okay, let's from here. Okay, this is okay. Let's bring this down a bit. Let's continue from here. Okay, this looks cool. Let's take this off. Let's take this off a bit. Let's take this off. Okay, let's take this off. Yes, we got it. We got it here. So this is our curve. This is our curve. Although it's not really perfect, but this is our curve. This is our curve. This is the graph for y equal to 2x squared minus 5x minus 12. Let's write that. It's good to always write this close to the curve. Write the relation close to the curve. Y equal to 2x squared minus 5x then minus 12. That's the graph for that relation. That's graph for that relation. Now let's answer the question here. The question says use the graph. We've actually answered this B part. The next part says use the graph to find y when x is equal to 1.8. Let's find y when x is 1.8. Now we don't know what one box here represents. So to get what one box here represents, what you just do, just say, you know, the first number here where is 1. So you say 1 divided by, you know, we have 10 boxes before we get to 1. So that will be 10 boxes. So 1 divided by 10, this will give us 0.1. So it means each box here represents 0.1. The two boxes represent 0.2, like that. So we need 1.8. It said when the question says when x is 1.8, find y. So when x is 1.8, this is 1. So it means 1.8 to be somewhere here. Since one box represents 0.1, 1.8 to be somewhere here. Yeah, this is 1.8 there. So we're asked to find y when x is 1.8. To do that, we'll just trace this down to the curve. We'll draw a straight line down to the curve. I think this, okay. Draw a straight line down, draw a straight line down to the curve. Draw a straight line down to the curve. Then trace this to the y-axis. We'll trace this down to the y-axis. We'll trace this to the y-axis and we'll have, let me use another color. We'll have something like this. Let me use black. We'll have something like this. You see, this is the point. This is the point where the line touches the curve. This point here. So you trace it to the y-axis, trace this to the y-axis, trace this to the y-axis. So this point is, now this is minus 14. Now if this is minus 14, this is going to be minus 14.5, minus 14.5. So it means when x is equal to 1.8, y is equal to minus 14.5. That answers the aspect. So we have y is minus 14.5. Now the next one says find x when y is equal to 8. So let's go to the graph when y is equal to 8. So this is minus 5. Two boxes give us minus 6. Two boxes give us minus 7. Two boxes will give us this is two boxes minus 6. Two boxes will give us minus 7. Two boxes here will give us minus 8. So this is minus 8 here. That's minus 8. Just draw a straight line. We'll draw a straight line through to the curve. Draw a straight line to the curve. That's one. Then draw again to the other one. Yes, like this. Then you trace this up. You trace this up. You can trace this up, or just stick it like this. No, this doesn't look cool enough. Let's take this up and take this up like this. Take this up like this. Can take this up. Okay, this is where it touches the x-axis. So we'll take this one up to take this one up, so take it up, take it up, take it up. This is where this also touches the x-axis. This is where it touches the x-axis here. So this point here is 3.1. This point here is, since one box represents 0.1, this is going to be minus 0.1, minus 0.2, minus 0.3, minus 0.4, minus 0.5, minus 0.6. This is minus 0.7, minus 0.7. So it means when y is equal to minus 8, x is equal to minus 0.7, and x is equal to 3.1. That answers the second part. So that's all.